Hello students, how are you today? Hope you're feeling good. Peace, mercy and blessings of God be upon you. In this new circuit, I'm going to explain to you the method of controlling a motor or a three-phase motor using the star-delta connection, which is one of the classic control circuits or the important industrial control that is widely used in most productive factories and commercial establishments. Of course, we explained in the previous lessons what is the idea of the star-delta and why do we connect the motors using the star-delta method and not connect them using delta-star method or by direct methods. There are other methods used to start the motor, such as soft starter and inverter. Of course, this is a circuit that we will explain in detail now from A to Z, how to connect it and how to operate it. Of course, it's as if you are in a practical laboratory in front of you, an electrical panel, and you want to collect these components, connect them, operate them, and check their work. We hope that you will get benefit from it, and we hope that you will have a distinguished presence with us. I explained in the previous lesson the idea of connecting the star-delta and why do we connect them. Many of us know that it is connected, but a few of us don't know the reason. Sure, we mentioned with examples, calculations and numbers why most of the large power motors were connected star-delta. It's known that the motor, when running, draws a high electric current. Any motor or any motor with especially large power consume always from 5 to 10 times the rated current or the full load current. This results in a rise in the temperature of the internal windings that may lead to the combustion of the motor. The difference in the intensity of the starting current makes us connect the motor to star-delta. The idea is that simply starts the motor rotation through the star connection. Always the delta current is equal to the star current multiplied by the root of 3. This means that the delta current is greater than the star current with an increase of 57%. In the case of connecting a star, the voltage of the star is equal to the delta voltage multiplied by the root of 3. This is if I need a delta connection, the voltage is lower while the current is higher and vice versa. In the case of the certain connection, the voltage is higher and the current is lower. Let's explain it to you as we mentioned in the previous lecture in numbers briefly. This is a practical example with numbers that shows the difference between star connection and the delta connection. Firstly, in case the motor coils are connected using the star method, the source voltage is not equal to the voltage of the coil itself. The coil voltage of the motor is 380 divided by 1.732 and equals 220 volts on the same coil. While the opposite in the delta connection, the source voltage is equal to the coil voltage and equal to 380 volts for each of them. Secondly, if we assume that the resistance of the single coil of the motor is 10 ohms for each one, let's see the value of the ampere withdrawn in the star and the delta cases, and accordingly the value of the starting current will take the same exponentially. Then the current in each coil equals 22 amperes. If we assume that the motor starts at 6 times the rated current, then the starting current will be equal to 132 amperes. While in delta connection, the current equals 380 divided by 10 ohms and will equal 38 amperes. If we assume the motor starts at 6 times the rated current also, then the starting current will be equal to 228 amperes. Thus, we notice the starting current of the movement in the delta state is greater than the star with an increase of 57%. In other words, the motor at the beginning of the movement or rotation when a star is connected works at almost half of its capacity at a value of 57%. So we put it star and then delta in order to avoid the intensity of the high starting current. We go back to connecting the complete circuit. Connecting method. From the main network and then to the main cable feeding the factory or facility, I have 3 hot lines RST and the neutral line. We take 3 phases to the main circuit breaker that works to fully protect the power plate, and then to the main contactor responsible for the feeding the motor and turning it on or off, and then to the overload. Which is the device responsible and sensitive to protecting the motor mainly at the value set on it. Meaning, if we had the full load of the motor 10 amperes and set it to the value of 10, if the ampere rises to 10.5 amperes, the motor will be disconnected immediately in order to protect the motor from any rise in temperature that causes the motor to burn. Then we will come to the motor board, and as you can see, it consists of 6 points. The first 3 points are the first sides of the 3 coils, and these are the exit sides or points. Alright. Now, this KM contactor is always on and is responsible for feeding the motor with electricity. We take 3 points from the 3 faces to the contactor that works to connect the motor in the delta connection. And then we take other points to another contactor that works to connect the motor in the star connection in this way. If we looked at the terminal coils connected inside the motor, we will find them in the second form. There are 3 coils. Each coil has a beginning and end, meaning the first coil has a first starting point and has a second point which is the end, U1 with U2. This is the first point of the coil and this is the second point of the same coil between U1 and U2. As for the second coil also V1 and V2, and as for the last one or the 3 coil, W1 and W2. The ends of the coils are designed in the way in order to facilitate the process of converting between star and delta connection. So this is how the power circuit will be, and it will consist of 3 contactors. 1 main contactor and the other 4 star connection and delta connection. In the event that only the star contactor is running, it will look like this. Electricity input passes from the network through the breaker and the main contactor, then to the overload, then to the 3 motor input terminals U1, V1 and W1. The 3 output terminals of the motor are connected at one point through the star contactor, as you see here at this picture. In the event that only the delta contactor is running, it will look like this. The electricity input passes from the network through the main circuit breaker and contactor, then to the overload, then to the 3 motor input terminals U1, V1 and W1. And the 3 output terminals are connected to the phases in delta connection. This is how I have the power circuit connected correctly now. Before we connect the control circuit, let's identify the elements used in this circuit. The main circuit breaker, responsible for the control circuit. the start button, the stop button, and the timer. These are the important elements that we will use it in the control circuit. The timer has many forms and many types, including that works on 220 volts at AC voltage and 24 or 12 DC voltages, depending on the user you have in the circuit, including components and voltages that you want and are available in the network. In this circuit, we need a 60-second timer, as the gradient allows up to 60 seconds, but I can set it to 5, 6 or 7 seconds as much as you want. But I don't need minutes or more because I just need a transition to the power circuit from a connection start to delta connection in a few seconds. You don't want it in a very long period of time. Alright, as for the contacts and their positions, and what I'm going to use in this circuit, I will use the open contact point in the start button and a closed contact point in the stop button. I will use the open contacts in the main contactor of the motor, but I will not use the closed contacts in it, but I will use the closed contacts in the other two contactors responsible for the star and delta connections. I will use closed contacts between points 96 and 95 in the overload. I will use the open and closed point together in the timer, and each timer has a connection map drawn on it, meaning each map differs from other based on the manufacturers of timers. At this timer, between 11 and 12 a closed circuit, and between 12 and 14 open circuit, and the point 12 is always common, C. Now, I'm going to connect the control circuit from one of the faces to the main circuit breaker for control, and then to the closed contact points 95 and 96 in overload, and then throw to the stop button and then to the start button. And we don't forget this important movement that we talked about previously, which is the electrical lock. Its function, as we mentioned, if as soon as we press the power button and lift my finger from the others, the circuit turns off. But when I raise my finger, it will keep the circuit running because it will take another path in this latch or the lock and keep the circuit in the running state. Okay. After that, we complete the connection from the power button to A1 and the main coil of the contactor, then exit from A2 to the neutral line. We will take a point from here and complete it, then connect it to the timer. And we must connect the timer with a voltage of 220 volts between the phase and the neutral. If we assume the voltage between the three phases is 400 volts, then we will exit from point neutral to the line. We will take a point from the same voltage or from the same line there to the common point C. And we take from point 11 to the closed auxiliary points of the contactor supporting the delta contactor, then entering the star contactor coil to A1 and exit from A2 to the neutral line of network. My friends, question: why didn't we connect directly from 11 of the timer to the star contactor coil directly? Is this called the electrical interlock or electrical protection? In the event that the star contactor works, the delta contactor shouldn't work, because if electricity returns by mistake, it prevents the passage of the electric current to the delta contactor coil, and thus an electric short will occur in the circuit. From point 14 of the timer, we take a path to the closed contact points of the star contactor. Then throw the delta contactor coil A1 and exit from A2 to the neutral line. Thus, the control circuit has been connected correctly. If the circuit is running, we will look together step by step to see what will happen. Now, the operating. In the operating state, of course, we raise the circuit breaker up, meaning that we operate the breaker so that the electric current passes from the distribution network, and we press the start button. In the event that we press the start button, the position point changes from normally open to the normally closed, meaning it's now closed. If it was closed, what will happen? The electric current passing through the circuit breaker, which reach the overload through this closed point 95 and 96. Then to the stop button, the closed state, and then to the start button and the loop located here, so that it feeds the coil following the motor responsible for feeding. Thus, the electricity entered completely and returned to the coil, which led to turn on the contactor Km and complete the circuit, and the electric current passes through the timer. We took it from point 12, which is a common point, and the current will continue to pass in the closed path, as you see here. Thus, the electric circuit entered the control elements from the circuit breaker to the overload, then to the main contactor Km, then to the timer. So the timer works for 5 seconds now, and then to the star contactor Ks. Ks works at the same time with the contactor Km. The 3 input terminals of the coils in the motor were connected to the power circuit through the main contactor Km, and 3 output terminals of the coils of the motor were connected to the star circuit through the contactor Ks. Now the motor is ready to run, and it all works at the same moment. If I set the timer to 5 seconds, it will count from 1 to 5 seconds, and at the same time the timer will transfer the state of connection from star circuit to delta circuit. Let's show you. 1, 2, 3, 4, 5 seconds. Now the timer will change its positions and will convert the circuit from star to delta circuit now. The first time the star contactor starts to work, the timer will count 5 seconds as 1, 2, 3, 4, 5, and then the closed contact points will turn into open and vice versa. As the timer changed its status now between 12 and 11, it became open, and between 12 and 14 became closed. And thus the circuit was separated from the star contactor and was stopped. The contacts in the star contactor returned as they were, and at the same time the electric current was passed in the path to the delta contactor, as you'll see here, and thus it was activated. In sum up, we disconnected the star contactor and activated the delta contactor. I mean, we actually disconnected the star contactor as soon as the timer changed its position after 5 seconds. The control circuit was separated from the star contactor and worked on the delta contactor. The motor continues to rotate after its connection moves from start circuit to delta circuit. The whole process takes place at the same moment and the motor is running. Okay, what happened in the case of delta connection? The 3 main input terminals of the motor have a voltage of 400 voltages. For example, while the three output terminals of the coils are connected to the delta circuit in the same order as the three phases blue, yellow, and red. The star contactor is now dismissed. Let's quickly re-explain the idea and discuss again. We lift the main breaker for control and press the green start button, and as you can see, the electricity enters, the K-amp contactor works, and the electricity enters the timer and then to the star contactor, and the motor works and the timer starts continue counting 1, 2, 3, 4, 5 seconds, and after 5 seconds the timer changes its settings from closed to open and vice versa. After the star contactor was separated, the delta connector will work now. If you want to disconnect the motor, go to the stop button and press it. What will happen? The entire control circuit will be disconnected, because as soon as the stop button is pressed, the contact inside the button becomes open, and thus the electric current is cut off from all the circuit and the circuit components Km, Kd, and Ks. We thank you, dear friends, for listening and watching. And if you have any questions, I'm ready to answer you. Gives you a wellness.